Hi, I'm Chris Ward, and in this latest video, I want to demonstrate how easy it is to be able to set up the 3RW40 soft starter. So, as you can see on this main slide here, you've got some of the newer soft starters, or the majority of the soft starter range, and the one that we're going to be looking at today is the 3RW40. So we'll just move on to the next slide now, and this just gives you an overview of the actual device's configuration. And this tab here, which is labeled number 1, is where your mains in feed comes into, and tab 17 here is the output to the motor terminals. In a similar fashion to the 3RW30 here, you've got number 2, which is labeled A1 and A2. So that's for the control supply voltage. You need the power to your control circuit, and you also need power to this terminal here, number 3, which is actually labeled terminal 1. So you need the control circuit to be accessed, and you also need terminal 1 to be initiated to gain a start sequence of this particular soft starter. Terminals 4 and terminals 5 that are labeled here, they're for signaling, so they're not compulsory to connect in, but they can be particularly useful if you wanted to know or gain an indication of how the device is running, whether it's in on or it's entering the bypass mode. There's multiple different LEDs which are labeled here for number 6 and number 7, which give you an idea of the operation and the general state of the soft starter and its diagnostics. There's a reset and a test button on the front of the soft starter, which is this blue button here. And then, as you can see, there's 5 different potentiometers which you can use to program the soft starter. So that's how you parameterize the soft starter, is by processing these 5 potentiometers on the front of the device. So they're compulsory to set them right to gain an efficient startup of your motor. So this first one at the top, this one that's labeled number 13 and covering it, is this orange arrow, and it actually says class there, and you can decide. This device basically has a built-in overload to it, so there's class 10, 15 and 20 on there. Class 10, a start up to 10 seconds on the overload. If you have a 15-second startup, use class 15 or under, and if you have just under 20, use the class 20. Or if you don't want to use the overload function, you also have the ability to be able to turn that off. This pot here, number 14, as you can see, this is actually the motor's current rating. So on the nameplate of the motor, it'll suggest what the general operation will be of that motor, and that's what you set that potentiometer to. This next pot at the top right indicates the current limitation function. So with the current limitation function, that can have a bearing on how the soft starter starts. So a soft starter typically functions through voltage regulation, but if this current limitation function was set to, say, 2 times the rated current, and during the startup you would typically achieve 4 times the rated current, what would happen is the soft starter would regulate the current to that 2 times the rated current until it reaches the full speed. But if you don't reach the full line voltage within the time frame that you've set the pot below it for the ramp up time, what that'll do is it won't have reached the bypass mode and it won't switch out and it'll go into fault. So it's really critical that you get you set this pot to the correct amount. Some people opt to put that to the maximum value, which would be five to seven times the rated current. Which means effectively this pot would be bypassed. Another common error is that people generally tend to oversize soft starters, undersize them, and that can cause faults with the soft starter. So it's not that the soft starter doesn't actually work, it's that they've undersized the device. So if you've got a device which is seeing 10 times the rated current on the soft starter that you've selected, then the chances are by the time that the device is actually the ramp up time has elapsed, the device still isn't up to full speed. So when it switches into bypass mode, what will happen is the device will just go into fault and shut down. So the soft starter won't be have the correct power requirements to get that motor up and running. So it's really critical in the selection process this to get this potentiometer correct to ensure that the motor is going to be able to start up. The pot below it here is for the ramp up time, so that can go from 0 to 20 seconds dependent on the time that you desire. It's not an accurate potentiometer. It will get the soft starters aren't meant for precise starting and stopping times, so it's a rough estimation as to how long it'll take that device to run up to full speed. So if you want to use voltage control as opposed to current control, you would turn this potentiometer to the full amount, and then you would use this voltage ramp up time to effectively control the voltage up to the full line voltage. Here with pot 11, this also gives you a pedestal voltage. So the pedestal voltage is what voltage you want the application to start at. So if you had 400 volts application and you set that pot to 50%, then it would take X amount of time from what you've set this potentiometer to for the ramp up to reach the full line voltage. So say if you had a particularly arduous load, say for example a crusher, then it might be wise to select a higher starting voltage, because you're going to need a higher moment of inertia for a more arduous load. But the older way of parameterizing soft starters, you needed a lot of trial and error to be able to get all these pots to the desired requirements, because you don't know what each of these pots are until you start guesstimating what you think those pots might need to be for that particular application. And then this last pot here is for the ramp down time. So when either of these three terminals, the voltage has been removed or the signal's been removed, then the device will coast down to 0 RPM in the time allocated here, and it's similar to the ramp up time here, so it goes from 0 to 20 seconds. In this terminal here, as you can see, terminal 15, so that is where you can have an evaluation of a thermistor module which is connected to the motor windings. So it has inbuilt thermistor function, but only on certain configurations of the 3RW40 is that an option. And then this last terminal here, terminal 16, is another signaling contact for a fault. Which you might want an illuminated push button to raise an alarm, say for anything that was untoward, or something was flagging up on the soft starter which was in the control cabinet. You might want to view something on the front of the control panel instead. So on this next slide, it just gives you a bit of an idea as to how you'd wire the soft starter. So it's very, very similar to the 3RW30 in terms of the configuration, except it has a couple more features on there in terms of signaling. Now on the 3RW30 you don't have options for signaling for an overload failure, or you also don't have a signal to say that the device has gone through the bypass mode. So with the soft starters, the way that they work is when this device is switched on, the power and the voltage runs through these power semiconductors here, and they continue to do so until you've reached the time that you've allocated on the potentiometer for the ramp up. And if the device has reached the full operational voltage by that time, these thyristors will then be switched out by this mechanical bypass, which is what this contact is actually signaling. So the idea is that now you've got an extra signaling contact here, and it works in a similar kind of fashion. Once you've removed A1 and A2 or the in signal from the soft starter, this mechanical bypass will then unlatch and the device will power down through these thyristors. So the way that the device would be configured would be you have the 3RW40 here in this main circuit. So 3RW40 will take care of the starting of the motor, so in turn it has like mechanical contacts in there that does the switching on and off of the motor, but you also have integrated evaluation for your overload protection of the motor, and you also have the missed evaluation if you wish to, dependent on the options that you select. Upstream of the device, it's always critical to have a form of short circuit protection. That can range from fuses to circuit breakers, dependent on what type of coordination that you're trying to achieve. So in this control circuit here, similar to the 3RW30, you have your in signal, which is going to this terminal 1. So terminal 1 is for in. On that signal you'll have a start and a stop command for the motor, and on A1 and A2 you also need to initiate the control voltage to ensure that the device starts. A1 and A2 have to be in use, and also the signal to terminal 1 has to be engaged for the motor to actually initiate a start. If you hold a push button in for 1.5 seconds, that will automatically reset the soft starter for you as well. And it's as easy as that to be able to connect the device into and get it up and running in terms of the control circuit. You don't actually have to have any of the signaling. That is optional, so you can signal that there's an overload or a potential failure if you wish to with this bypass contact. And then similarly there's also a signal contact here which is called bypass, which we brushed on earlier, which basically gives you a signal to tell you that the device is going through a startup or a stop procedure. So that is the way that you would connect the device. On this next slide, I just wanted to show you in the user manual. This basically gives you the older operation for connecting a 3RW40 in terms of its commissioning process. And the old hat way is you'd have a little look down this list, and it'll give you a few suggestions dependent on what you'd set those pots to. So these only cover 4 of the pots. There's 5 pots on there. There's one that is missing in terms of the overload, so you don't know what to set the overload with this particular graphical representation. But it gives you a rough idea of what you might want to set those pots to. But these kind of applications, that it's not a one size fits all. You might have a full conveyor belt, or you might constantly have an empty conveyor belt, and those different starting parameters, that they would be different starting parameters for an empty conveyor belt than it is to a full one. So it's really it's really down to an end user to sort of trial and error what those potentiometers are to be. And as you can see here, you've got a bit of a ladder or a flow chart which basically depicts how you would react under the various different scenarios that are the outcomes dependent on what you've set those pots to. So the older commissioning method for using soft starters and for programming them was it was guesstimating. It was done through trial and error. It was all done through does that work? Does this parameter set work? No. Okay. Well, let's tweak the starting voltage. Let's up the ramp up time, and you go off trialing and second guessing what you might need to change. And now I've discussed that part with you. I wanted to show you that the new method in which we've come to harness and adopt. So one of the main bugbears for customers was how hard it was to set those potentiometers, and Siemens has worked hard on trying to appease their customer base by using a simulation tool which you can use to calculate those parameters for you, and that's what I'm going to show you now. So in one of my previous videos, I showed people how to utilize the Siemens STS tool. So if you haven't seen this piece of software before, I'd recommend that you go to one of my previous videos, which explains in detail how to set the soft starters up and how to select one and simulate an application. But for this video, the main intention is to show you the application parameters. So once you've filled in the three boxes for the environment and the supply, the motor and the application type, and we've gone for pump for this particular application, you can then dive into these application parameters. And as you can see here, you've got two graphical representations, one for torque and speed, one for current and speed. On here, you've got the soft starter simulation, which is this yellow line here. You've got a DOL, which is this blue dotted line, and you've got the load torque line, which is here. And the idea is that we can now optimize our motor startup before we've even purchased the unit. So we now know what to set the potentiometers to. So this first pot here is for the starting current, and the idea is that this yellow line can't intercept with the load line, because if it does, the motor won't start. So we can now gain an understanding of what we can set this current limit function to for it to be a successful startup of the motor. So as you can see here, if we drop it too far, you'll get an error in this bottom corner which will tell you that the motor won't start. But then we can also increase it slightly, and now we know that we can use or set this starting current to 3 times the rated current, and we know that that will start the motor successfully. We can up it even further if we want to not utilize that function to the maximum. And then once that's been done, what we could do is we can switch the starting current limit function off, and we can say, okay, let's rely on the starting voltage instead. We don't want to regulate the voltage and have that overriding or being overridden by the starting current. We want to use the starting voltage instead, and then you can parameterize here what the starting voltage could be from the full line voltage. Do we want it at 100%? Do we want it at 25%? It's entirely up to you to gain an understanding of the starting parameters through this simulation tool. So we could rest assured knowing that if we set this starting parameter voltage to 70%, and then we change the ramp up time here from 10 seconds to say 5 seconds, we've had no message in this bottom right hand corner to say that the motor isn't going to not start. Those parameters are sufficient to get the motor started. We can now rest assured that we now know that what the starting current needs to be for the current limiting function. We also know what the starting voltage needs to be for this application, and now we know that the ramp up time can be suitably selected for 5 seconds. Moving on from that, if you go into this disk here, which has a list of suitable soft starters for the application, and we go into additional functions, here you can see the overload is actually off. But if we go into additional functions and scroll down, you can actually go in and select motor overload, and then what that'll do is it'll tell you what you need to set that overload setting to. So that is a great function to have. So there you now know what you need to set all the pots to get the motor to start. The ramp down function doesn't actually cause any particular problems to the motor, so that one's not been included because that will work, that function will work regardless of what you set it to, because all you're doing is removing the control voltage and then it will just coast down naturally to 0 RPM. It will try and regulate it dependent on what you set that ramp down time to, but it's not going to cause any issues with the process of starting and stopping, so that's why it's not being included. And once you've done that, you can then take a look at the report which has been generated afterwards, because you can go, once you've done that, you can select the suitable soft starter, you can go into report, have a little look at the coordination, and you can get the short circuit protection added in here, and then you can go and generate a report. And what you get from that, as you can see here, you get suggestions for the short circuit protection, which is great because all these combinations have been tested to the latest IEC regulations. It gives you options for motor circuit breakers or fuses. It even promotes an optional line contactor, but that's not necessarily required. It is optional because the device has an integrated bypass. And then it gives you the starting parameters here, which it suggests for that particular application. So it gives you all the information that you can then include in your project and what you need to set those parameters to. So really what I wanted to drive home with this presentation is that Siemens have moved away from the trial and error. There's no more guesstimating as to what you need to set those potentiometers to, because you can actually simulate everything within this application tool before you've even bought the unit. So you'll get a more optimized motor startup by using the tools which are at your disposal. So I hope you found the video useful. Please stay tuned and look ahead for some of my newer videos which will be coming out very shortly. Thanks very much for watching.